Hi, this is lesson 11.1 and 11.2. We're going to actually do two lessons together. So we'll be filling in quite a few of your frames, the first 2 pages. So the big question here is, when will the mean of a data set differ significantly from the median of a data set? Now, one thing you want to make sure is you have your graphing calculator out, because we will definitely be using your graphing calculator quite a bit in this lesson. Okay, so look at your 11.1 frame. It says measures of central tendency is about using different statistics to compare and summarize sets of data. So measures of central tendency, central means middle, really, tendency. So we're kind of looking at what happens around the middle of a data set. Also fill in your mode, or your so what down here at the bottom. It's the mean, median, and mode. All measure the middle, but in different ways. So we're looking at really 3 different ways of measuring the middle of a data set, just different ways. So our mean, okay? Our mean looks like this, okay? We use that symbol to represent mean, x bar. So the mean or average of n numbers is the sum of the numbers divided by n. So for this data set, if I have x1, x2, x3, all the way up to x of n, then x bar is x of 1 plus x of 2 plus x of 3 plus x of n. So we go all the way up and add all of them together, and then we divide it by how many there are. And this should look familiar. You've done average before. Now we're just giving it the name mean. The median of n numbers is the middle. It's the middle number when the numbers are written in order. So you have to make sure your numbers are in order from smallest to biggest. So if n is odd, there will be a single middle number. So if we have an odd number of terms, the median is your middle. So here's an example. If I had 2, 3, 4, 5, and 6, 4 is my middle term here. So 4 would be my median in this example. If n is even, so if the number of terms is even, then the median is the average of the 2 middle numbers. So if I had 2, 3, 4, 5, 6, and 7, well, 4 and 5 are both in the middle there, so we add them together, 4 plus 5, and divide by 2. So 4.5, that would be your median for that data set. Okay? So the mode, I'm missing my mode slide for some reason here. I'm going to go back to the very beginning and put my mode in on this original frame. So the mode of n numbers is the number or numbers that occur most frequently. So there can be 0 modes. If they're all your numbers in your data set are all only listed once, there's 0 modes or no mode. There can be 1 mode if there's only 1 number that has the most. Or there could be more than 1 mode. So I remember mode because it sounds like most. Mode, most. I remember those 2 words together. All right, let's go back through here. Okay, so example 1, the data sets give quiz scores for 2 different biology classes. Find the mean, median, and mode of each data set. Okay, so looking at this class A, I can easily see that 17, 17, and 17, that occurs 3 times. So my mode is 17. For class B, I can see that 22 occurs 3 times. So my mode is 22. Okay? And then to find my mean and my median, I'm going to actually show you how to do this on your graphing calculator. Okay, I'm going to show you how to find the mean and median because you've done this before. I know you did this in different math classes. So now we're just going to take the time and use our graphing calculator to do this. So let me pull up my graphing calculator here. Okay, so here's my graphing calculator. It's on. What you do to find the information, the statistics on a data set, is you click on the stats button. So I hit stats, okay? I'm going to edit my list. So number 1 says edit, and I'm going to hit enter. And then I'm going to enter my data into that. So I'm going to enter 15 and hit enter, and then 17 and hit enter, 17 again, 17 again, 18 and hit enter, 19, 21 and hit enter, 22 and hit enter, and then 25 and hit enter. So I have all my data in there. If I go back and hit the stats button, it's just to the left of your little up and down arrows. If I go back and hit the stats button and then arrow over to calculate, number 1 says 1 variable statistics. So if you hit 1, it puts 1 variable statistics on your screen, and then hit enter twice. Or actually just once, you have to hit it. So up here where it says X bar, and I can't write it once, but let me get my graphing calculator back up here. It switches out on me. Okay, where it says X bar at the very top, that says 19. So 19 is my mean for this data set. And if I use my down arrow, it says MED. MED is my median, and that's 18. So for this data set, my median is 18. And my mean is 19. So my median is 18 and my mean is 19. So pause the video and take a second to find the data, the mean and median for Class B using your graphing calculator if you have your graphing calculator. If not, do it by hand. Okay, welcome back. You should have found that the mean for Class B was 21 and the median for Class B was 22. And if you didn't get that, look back, make sure you put your data in your calculator correctly. And if you still can't figure it out, we'll talk about it tomorrow, but I'll do another example here, so that might help clear it up a little bit. Okay, example 2. The data set gives the number of siblings in an Algebra 2B class. And you know what? I don't have any data set in here, so we're actually going to skip this one. I think 1 example is enough for this. Okay, so flip your frame over. Let's look at the back side of your 11-1 frame. So 11-1, the back side, the measure of dispersion is about the 2 ways, is about the 2 ways we measure how spread out data is. Okay, so measures of dispersion. Okay, disperse, if you disperse something, you hand it out. Measures of dispersion measure how spread out the data is. And we have 2 measures. We have range as one of them, and then standard deviation as the other measure. So first, let's look at range. Range is your highest value minus, it's a minus sign, your lowest value. It's that easy. Highest minus lowest. So if I want to find the range of Class A, the highest is 25, the lowest is 15, so 25 minus 15 is 10. So that's my range for Class A. For Class B, my highest is 25, my lowest is 16, so 25 minus 16 is 9. So my range for Class B is 9. Standard deviation. Okay, here's another measure of central tendency, and this is probably the first time you've heard of this. For standard deviation, we use this symbol, okay, and that's read sigma. Okay, sigma. That's a symbol we use for standard deviation. So standard deviation describes the typical difference or deviation or change between a data value and the mean. So the standard deviation or sigma of x1, x2, x3, all the way through x sub n is found like this. So sigma equals, we do our first data set value and we subtract the mean and then we square it. Plus our second data set value, subtract the mean, and then we square that. Plus all the way up to our nth data set, or our nth data, so x sub n minus the mean, and we square that as well. And then we divide all of that by how many terms there are, and then we take the square root. So there is a whole lot that goes into calculating the standard deviation. The good news for you is you do not have to do that all by hand. We are just going to use our graphing calculator. But I want you to make sure you realize what standard deviation does is it describes the typical difference or deviation between a data value and the mean. Okay, that's what standard deviation does for us. So for example 3, it says find the standard deviation for quiz scores for class A, and that's 15, 17, 17, 17, 18, 19, 21, 22, and 25. Okay, so the mean of this one we already found. Our mean for this class A was 19. Okay, so we could easily go through and calculate it by hand. It wouldn't be tough, but it would take a while. So instead, I'm going to show you on my graphing calculator where we can find our standard deviation, or sigma. So sigma equals, I'm going to get my graphing calculator up here. So here's my graphing calculator, and if you look at the screen that I'm looking at, the top one has x bar equals 19, that's your mean. And then if you look down below that, right above n equals 9 is your number of terms, right above that, it says sigma x. And sigma x, I can close that box, sigma x, that's your standard deviation. So it's 2.94. Okay, 2.94 is our standard deviation. And actually, let's do 3, no, we'll just do 2, 2.94. So my standard deviation is 2.94. So yay, we don't have to go through and calculate that all by hand. You can just use your graphing calculator. You have to know how to use it though. Okay, find the standard deviation for the quiz scores for class B. So why don't you put that into your calculator and find the standard deviation. Pause the video. Okay, so for class B, did you find that your standard deviation is 2.71? That's what you should have found. The next question here, which set of data, class A or class B, is more spread out? So for class B, it's 2.71. For class A, it's 2.94. So for class A, the average distance from the middle is 2.94. For class B, it's 2.71. So because the standard deviation for class B is smaller, okay, they're closer together. Class A then is more spread out. So our answer here would be class A, because the question's asking which set of data is more spread out. So class A, because the standard deviation, put the sigma value instead of standard deviation, is higher. And that's how we know the data is more spread out. Okay, so we're going to examine the effect of an outlier. So an outlier is a value that's much greater or less than most of the other values in a data set. So the winning score for the first 9 games of the soccer season are 3-4, 2-5, 3-1, 4, 3-3. We want to find the mean, median, mode, range, and standard deviation. So I'm going to get my calculator here, so you should get your calculator out. And that's not what I wanted there. Get your calculator out and we'll look. Plug these in. Okay, so I'm going to go back and hit stats again. Option 1, edit. Okay, we're going to hit enter because we want to edit this. So now let's enter our new data set in here. So we have 3, and then hit enter. You can enter it right over the top. Just make sure you clear out any data values that you don't want. Trying to be really careful, make sure I get the values in here. 3, 1, 4 now, 3, another 3. Okay, and I don't have any leftovers. There's no other values from my previous set of data that I need to delete, so I've got it fine. So if I hit stats again, arrow over to calc for calculate, we want number 1 variable statistics. So if you hit enter 2 times, okay, hit enter twice, it'll give you your values. Okay, so first of all, our mean is about 3. If I scroll down, so actually our mean is about 3.11. We'll put 2 decimal places in there. So our mean is 3.11. our standard deviation. Now these values look a little different than what I have, so I'm going to look back at my stats and make sure that I put my data set value in here. So stats, let's edit it. Let's make sure I have this all in here right. So I've got 3, 4, 2, 5, 3, 1, 4, 3, 3. Yep, so I have got my values in there right. So it's always good to make sure we've got the right ones in here. So arrow over to calculate, enter twice. Okay, so my mean is 3.11. That's my X bar. My median, actually my standard deviation is on this one right now as well. So your standard deviation is 1.10. Use my arrow down. Okay. My median is right there. My median is 3. My mode, you can look there for your mode. The value 3 happens the most often. And then your range, if you do your max minus your minimum, your range is 1. Okay, sorry, I had a phone call there. So my range is what I was talking about. My highest is 5. It says max. My minimum is 1. So your range is 5 minus 1, which is 4. So let's get those put on our frame here. So my standard deviation is 1.10. My range is 5 minus 1, which is 4. My mode is 3. My median is 3. And my mean is 3.11. Okay, so B, it says the winning score in the next game is an outlier. So an outlier is a number that's very different than the rest of the data. So the outlier is 9. So let's look back at our graphing calculator here. And we're just going to add that one more data value to our stats. So if I go back to stats, and one is edit, so I'm going to hit enter. And I'm going to keep all of these values in here, but I'm going to add one more. So I'm going to add the value 9. And let's see what happens. So if I go back to stats and arrow over to calc, and I want one variable statistic, so I hit enter twice. Okay, so now my mean is 3.7. So that changed just a little bit. My standard deviation is 2.05. That's changed a little bit as well. It actually changed quite a bit. It almost doubled. Okay, my median is 3. My mode, what happens the most, is still 3. And your range is now 9 minus 1, which is 8. So let's get those values put on our table here, or on our frame. So your standard deviation, oops, should go here, it's 2.05. Your range is 9 minus 1, which is 8. And if you look, your range changed quite a bit. So did your standard deviation. Your mean is 3.7, so that changed, went up a little bit, but not as much as your range and standard deviation. Your median is 3, didn't change at all. Your mode is 3, that didn't change at all either. So which measure of central tendency does the outlier affect the most, the least, and what effect does the outlier have on the range and standard deviation? Okay? So for our measures of central tendency, mean, median, and mode, it mostly affects the range. Okay? It doesn't have much effect on the mode and median. Your standard deviation is affected slightly as well. And that's the end for 11.1. Now we're going to look at your 11.2 frame. So look at 11.2. It's apply transformations to data. This is about how data is affected when you add a constant to each value. So we're first on this side adding a constant. So when a constant is added to every value in the data set, the following is true. The mean, median, and mode of the data set can be obtained by adding the same constant to the mean, median, and mode. The same, or it shouldn't say the same, I changed this on yours, it should say the range and standard deviation are the same. So those don't change. Your range and standard deviation stay the same. So example 1 here, the data set gives the midterm scores for chemistry class. Okay, there they are. Find the mean, median, mode, range, and standard deviation for this data and write it in the table. So pause the video and try these on your own. Try to put them in your graphing calculator, see if you can get this. Okay, you should have tried this on your own and you should have found the mean is 90, the median is 90, the mode is 93, the range is 15, and then your standard deviation, your sigma, is 4.796. Okay? If you go through and add 5 to all of these, okay, add 5 points to all of these, put that in your calculator, what you'll find is they just all increase by 5 for your mean, your median, and your mode. Okay, those all go up by 5, and you can practice that by putting in your calculator if you don't believe me. Your range, that stays exactly the same because everything shifts up 5. And then your standard deviation also stays exactly the same. So a good thing would be to practice that. Try it in your calculator. Okay, so looking at the other side of this frame, we're almost done with it. Okay? So when a constant's added to every value set as true, we already did this one. I'm not sure why I had that in there a second time. We already have this one as well. I'm not sure why I put that one in there a second time. Okay, here's the other side of my frame. So 11.2, it's about how data is affected when you multiply each value by a constant. So that's what we're doing on the back. What happens when we multiply each value by a constant? So when each value of a data set is multiplied by a positive constant, the new mean, median, mode, range, and standard deviation can be found by multiplying each original statistics by the same positive constant. Okay? So here's our example. So our data is 19, 25, 28, 20, 27, 8, and 25. So again, pause the video, put these into your graphing calculator, and see what you get. Okay, welcome back. In your calculator, you should have found a mean of 21.7, a median of 25, a mode of 25, a range of 20, and a standard deviation of 6.41. Okay, so now we're going to find each value of a new data set if we multiply the original data by 2. So what you can do is you can go back into your graphing calculator, look at your values again in your table, and for each value just put times 2 at the end of it and it will calculate the new values for you. And then if you go and look at your mean, median, mode, and range, you'll find that your new mean is 43.4, your new median is 50, your new mode is 50, your new range is 40, and your standard deviation is 12.82. And you should be able to get those in your graphing calculator. So here's another example. Try putting these values for this. It says the data set lists the winning distances in meters in the women's Olympic javelin throw from 1968 to 2004. Find the mean, median, mode, range, and standard deviation of the distances in meters and in yards. So this would be a great example of when you might multiply everything in a data set by a value. Okay? So if you use these values right here, okay? These are our values in yards if you put them in your graphing calculator. So you should take a second to pause it and do that. You'll find that your mean is 20.87. Your median is 20.795. Your mode is 20.56. Your range is 2.82. And then your standard deviation, or sigma, is 89 hundredths. Okay? So to find and calculate this distance in yards, all you're going to do is multiply each of these values by our factor. So I'm going to multiply them all. Okay, multiply all of these values, and you should find for your new mean, you get 22.83. Your new mode is 22.75. Your new median was 22.75. Your new mode is 22.49. Your new range is 3.09. And then your new standard deviation is 0.97. So if you multiply everything by a constant, what happens is that your new values for your mean, median, mode, range, and standard deviation are all multiplied by that same constant. One last example here, what happens with the negative constant, okay? So if you put this data down here in your graphing calculator, you'll find that the mean is 15, the median is 14, the mode is 15 and 2. We've got 2 that are both listed twice here, so 15 and 2. Our range for this one is 15, and our standard deviation is 4.38. So if we multiply each of these by -2, what you'll find is your new mean is going to be -30. Your new median is -28. Your new mode, well, you're going to have -30 and -24. And then what will happen is your range is going to be just 30. And your standard deviation is just going to be 8.76. Notice my range and standard deviation, they're just multiplied by that positive constant. So your mean, median, and mode are going to be multiplied for this example by -2. But the range and standard deviation are multiplied by +2. So if you multiply by a negative constant, what happens? Your mean, median, and mode are multiplied by that negative number. Your range and standard deviation are actually multiplied by the absolute value of that number. So this is the end of lessons 11.1 and 11.2. Hopefully now you really know how to use your graphing calculator to help you find these statistics. And make sure if you have any questions, you star it so that we can talk about it in class tomorrow. Have a great day.